I'm going to solve one of the homework problems over here, but before I get to that, I'd like to just briefly go over the exponent rules, and you might want to have these written down on a small card or something. I hope perhaps you already have them on a card, if not in your mind. When you are adding like terms, you simply keep the exponent. All right. When you multiply, it doesn't matter if they're like terms or not, because you can add the exponent. If I have a 5 and a 3 and I end up with an 8, I must have got there by adding the exponents. Okay. When you raise to a power, all right. And by the way, I'm just showing you shortcuts. Sometimes these can be explained in a much lengthier way, but these are shortcuts you get away with using. Okay. When you raise to a power, you multiply the exponent. So what I like to say is I send in the 3 to each exponent. 3 times 1 is 3. 3 times 5 is 15. So we're left with 2 cubed x to the 15th. And then finally, when you're given a division problem, a fraction, the coefficients you reduce the same way you always have. 2 goes into 10 5 times. 2 goes into 26 13 times. But as far as these exponents, you subtract the exponents. Okay? So 7 subtract 3 gives you a 4. So this would be the simplified version of this expression. Okay? Again, you might want to pause this and write it if it's not real clear in your mind. One thing that's going on over here that isn't on this chart is, what does this negative in front of the exponent mean? And I'll address that now, and I'll zoom in a little bit on what we're looking at. When there's a negative in front of an exponent, let's see, this is this quantity to the negative 5. That negative sign actually means take the reciprocal of whatever I am attached to. Showing you how to take the reciprocal can get very involved and confusing. So I'm just going to use, at this point, I'm just going to use our rules for raising to a power. When you raise to a power, you multiply exponents. Okay, so basically I'm going to send this negative 5 in to multiply the 2 and to multiply that negative 5. And in case you're wondering, I can't just cancel this a to the second over a to the second, because each of these is contained within parentheses, so I can't get to what's in parentheses until I have to get rid of the parentheses, basically. Okay? And then on the bottom, I'm basically going to be doing the same thing. I'll send in our denominator, I'll do the same thing. I'll send in this negative 2 to each exponent inside. All right, so it's going to be negative 2 times a negative 1, negative 2 times a positive 2, and this 4 has an exponent of 1, so it'll be a negative 2 times 1. Okay, so let's see if we can get this written and get a handle on what we're actually looking at. I'm going to try to use my color coding, but it might get a little crazy. Alright, so this thing is, and in this case I'm going to write what I'm doing each step, but as you can see, it gets a little cumbersome. So this a to the second is going to be multiplied, by a negative 5. Okay, I better zoom in a little more. Then this b to the negative 5 is going to be multiplied by that negative 5. All right, I hope that's a little more clear. And this is all sitting over our 4. That's really to the first power, right? And we're going to multiply that by the negative 2, right? We sent in the negative 2. Then we have a to the second power. And we're going to, I might just zoom in again. We're going to multiply this 2 by this negative 2. Okay. And then let's see, we have b to the negative 1. Bring that over. And we're going to multiply b to the negative 1 by negative 2. Okay, and again, as you can see, this gets pretty involved writing it each time. So you're going to have to just do this in your head. You'll go crazy if you try writing it. All right. So let's, I think I'll keep going sideways a little bit here. Keep that line all the way. So a, 2 times negative 5 is negative 10. B, negative 5 times negative 5 is positive 25. Then we have 4. 1 times negative 2, negative 2. We have A, 2 times negative 2 is negative 4. And then B, negative 1 times negative 2 is a positive 2. All right, we still have some negative exponents. They are causing us trouble. I suggest get all of your exponents positive and then use these rules to finish solving what you're given. Okay, so this means a to the negative 10 means take the reciprocal of this and then raise it to a power of 10. To show you that, it gets very confusing. So basically none of these values are being added or subtracted, so I'm going to get away with a little trick here. I can in effect just take this a to the negative 10 and push it across the division bar, and it will become a to the positive 10. It's actually that simple. So anything with a negative exponent, I'm going to push it across the division bar. Whenever you cross this line, you change the sign of your exponent. It doesn't matter if you're going up or if you're going down. Okay? So, am I going to be able to keep going sideways? Yeah, I think I can. I'm going to take this, I'll use different color. Let's get these two in here. So 4 to the negative 2, I'm basically just going to push it up, and I'll get, I'm going to step way over here. I don't like this. That's better. Okay, so that 4 to the negative 2, I'm going to push it up over the division bar, and it'll become 4 to the positive 2. All right. This a to the negative 4, I'm going to push it up, and I'm going to get a instead of negative, it will be to the positive 4. All right. And then this b to the 25 is already positive, so I'll just leave that right where it is. Okay. And let's see, the a to the negative 10, this right here, I don't want that negative exponent, so I'm going to push that down, and it will become a to the positive 10. All right. And let's see, we already had b to the second on the bottom in our denominator. So that sits there. And there's our division bar. Now I can just use my rules here. I'm going to slide this back in. When you're dividing, you're going to subtract exponents. Okay. Again, I'm allowed to just think of it as pushing it back and forth across the line because nothing's being added or subtracted. Okay, as soon as we have anything being added or subtracted, don't try this. You're not allowed to do that. But if I show you taking the reciprocal, it gets so confusing to look at. Just learn the shortcut, the little trick, okay? So now, and I'm going to use a little bit more shorthand here. I have a to the 10 and a to the 4. What I like to just say is the smaller value is going to disappear. So a to the 4 is gone. I subtract 4 from 10 and I'm left with 6. I have b to the 2nd and b to the 25th. So the smaller one is going to go. All right. So b to the 2nd is gone, and I subtract 2 from 25, and I get 23, and 4 we can just square that. Okay. So for all our trouble, we will end up with 4 squared is 16, b to the 23rd, all over a to the 6th. Again, I'm just using some shortcuts and shorthand here, but to a large extent, to write everything I'm doing, it ends up looking so confusing. You're better off just doing this in your head and proceeding in that manner.